Okay, so active transport is another type of transport, or another process we use to transport substances across a plasma membrane. Unlike all of the other ones, so the other ones being diffusion, facilitated diffusion, and osmosis, active transport is transporting the dissolved substances against their concentration gradient. So we said all of the other processes were passive. They didn't require an input of energy, and substances moved down their concentration gradient from a higher concentration to a lower concentration. In this example, it's not passive, it's active, which means it requires an input of energy. That's in the form of ATP, and that's because we're actually pumping substances against their concentration gradient, so we're actually pumping them from an area of low concentration to an area of higher concentration. Because we're going across the plasma membrane, we're going to use a transport protein, and it's going to be a carrier protein, but a specific type of carrier protein that we call a protein pump. And just think, active transport needs a pump to pump something from low to high. So if we set up our plasma membrane down the bottom here, like we have in all of our other examples, and remember it's a lipid environment, and when we're doing active transport we're going to be transporting hydrophilic substances, so they're not going to cross that lipid environment, so we're going to need to put that protein pump in there, and we'll draw that in the middle. Won't be a great drawing, but it'll do the job. So our protein pump is going to be a transmembrane protein, a protein that goes from one side of the plasma membrane to the other. That's going to provide our nice hydrophilic environment for our substances to cross. And remember we said we're going to need some ATP, which is a form of energy. So our pumps, not only are they a transport protein, they actually have an enzyme element to them that catalyzes a reaction to utilize that energy from converting the ATP into ADP. So essentially what's happening, this time we're going low concentration to a high concentration. Let's take a substance, we'll do it like that. So say there's two. We'll call them, let's make it an ion. Let's make it calcium. And then on this side, we've got a higher concentration. So we've got two calciums on one side, 1, 2, 3, 4, 5, 6, 7, 8 on the other. And with the aid of ATP acting as energy and the passageway being a protein pump, the calcium ions can go against their concentration gradient, travel through the membrane from an area of low concentration to an area of high concentration.